So hello guys, so there is a question on the fluid mechanics, and question says that a boat carrying a large number of stones is floating in a water tank. What will happen to water level if the stones are unloaded into water? Okay, so the situation is I have drawn in the diagram. You can see there is a boat and there are stones kept on the boat and it is floating over water. What will happen if these all stones are thrown into this water? What will happen to this water level? So initially you can take the water level is some small h. Okay, and we have to consider, because nothing is given in question, you can say that the base area of boat is a. Okay, or actually we can consider base area as a, h is height, and mass of these stones we can consider. Okay, I'll write here mass of stones. I can consider small mass m, all stones. Okay, all stones is m, and mass of boat, because it is not given in question, so I'll take mass of boat equal to capital M. Okay, and initially I have written here area and h. So, and I can also take that initially when it is floating, when boat plus stones floating, what will happen in this case? Total forces in y direction, you can say, should be balanced. Okay, so total force in y direction should be balanced, and we can see free body diagram. Okay, so total mg will act vertically downward. m I can say m total into g will be vertically downward, and buoyancy force buoyancy force will act vertically upward, means buoyancy will act vertically upward, and m total will balance buoyancy force. Okay, so I can write that buoyancy should be equal to mg, m total into g. In m total I'll write mass of boat plus mass of stone plus mass of boat into g. How to write buoyancy force? That is okay, so density of water was not given, so I'll take density of water, rho. Okay, so density of water is rho, so I have taken density of water is equal to rho. Then volume of object inside the liquid or fluid we have to take. So how much volume inside? Okay, and g, this will be my buoyancy force, and it should be equal to small m plus capital mg. Capital M and small m are mass of boat and stone. Okay, okay, so we can go further, and actually we should also assume that this mass is m, and I can say density of stone will be rho s. I have denoted, or I can denote rho w by density of water. Okay, so density of this stone I have denoted with this, so I can cancel g. Now density, we have to find how much volume is inside water of the boat. That will be m plus capital M over density of water. Okay, this I can say. Now the situation, what question says? When all stones are thrown into water tank. Okay, so what will happen at in that case? I am again trying to draw some change in the water level will happen. Okay, actually water level will decrease, but with the calculation we have to see when all the stones are thrown into water. Okay, what will happen to water level, we have to check. Now again, if stones are thrown into water, we will use buoyancy, total buoyancy force that will acting should be equal to m total into g. So this time m total is only mass of boat into g, and buoyancy force we have to write. So buoyancy force will be rho of water, volume inside. Okay, volume inside water, and I can say that is initial, this volume will be different, so v dash inside. Okay, I am writing into g equal to mass of the boat into g. So now volume inside in situation second will be mass into rho w. Okay, so I can give name that equation 1, this is equation 2. Okay, so okay, so we have found, so we can equate by seeing both the equation. What will be your comment on this? So by observing 1 and 2, so you can clearly say that v inside in second case is, okay, that is m rho w, that will be greater than or less than v inside in first case, that is m plus small m rho w. Okay, this we can clearly see that this volume that is in first case is more, and volume, how can we write? Area into how much height it was having in the water. So water level will decrease. But there is a question, is what we are solving is correct or not? Okay, actually answer will be correct, it will decrease, but we are left with something. You should know then what will happen actually if stones are inside water. Okay, then they will contribute to increase in water level. Okay, so we have to consider this also, because we can't just say that it will be the answer that volume will decrease. We have to consider that thing also. So can you tell? Okay, so we have to consider that also when stones are thrown into water, because of their volume, how much volume, they will also displace some amount of water, and that will, there will be some raise in the height of water. Okay, so that we have to also consider, we can't neglect that fact, and because a very large number of stones are there. So okay, so now what will happen? So so we can consider, so now I am considering that because the stones are thrown into water large number, I'll say these are very collective, they are all together. Okay, and I know density is rho and total mass is m. So can you tell me how much volume they will occupy? Okay, so here in this case how much volume of water they will occupy and contribute to increase in level of water. So okay, so volume we can find, so volume, okay, volume increase they are doing by stones will be equal to, can we do like this, mass divided by density of stones. Okay, this will be the extra volume of water increase because of stones, because stones are now underwater. So now I'll again consider equation 1 and 2 with this with including the volume increase or height increase by stones. Okay, so initially the volume inside in case 1 was m plus capital M by rho water. Okay, after second case, so total volume will be rho by w, because this will be the volume of what inside that. Okay, so now plus this will be the volume, and how much volume, because stones are thrown into water, how much volume will increase? That will be mass into density of stones. Is this correct? Now this is equation 3rd, this is equation 1. Now you have to compare equation 1st and 3rd. Is it clear? I think because volume inside, this is volume inside finally v dash after modification, not modification because we haven't considered that stones are thrown and volume will increase. So now you can compare 1 and 3. So volume initially was this, okay, initially, okay, and after stones are thrown, the volume will be m by rho, then small m by ps. So what will be relation between them, you tell me? Okay, so it is easy to find. Now here capital M by rho is there and the same term is there. Now tell me, if you capital M by rho w plus small m by rho w, we have to compare them with this third case. So rho w plus m rho s. So now these two terms are same, so can I cancel like this? Now it it is clear that because rho of stone is greater than rho of water, because stones are sank, stone are because stones are underwater, okay, because stones, okay, so because stones are underwater, and because the density of stone is heavier, that's why they are sinking, okay, stone sinks. So what can you conclude? So conclusion is that because rho s is more than rho w, so the term, extra term or second term, so m by rho w, oh sorry, small m by rho w and small m by ps, because this is more, so this is totally, this is less, okay, so the volume finally will be this quantity will be more, okay, because this quantity more, v initially will be more than v dash inside finally, okay. And volume, we can say that volume is boat area into how much height. So initially area will be always fixed, so height, then you can say h dash, area, the volume inside in second case, after the stones are thrown into water, it will be area into h dash, so area will be same, and because it is greater, now initially h was greater, so h was more, and finally this h height is less, okay. So you can say water level will decrease, okay. Okay, so thanks for watching. This is about this question. I hope you got this concept, okay. Okay, thank you, bye bye.